Hello guys, welcome back with me Tsao 2025. Want fast AI videos without burning your GPU or waiting hours? Today we're going back to LTX 0.9.8. Yes, I know LTX 2 might be out, but this model is ridiculously fast. It's perfect for quick drafts and specific use cases. We're using the optimized 13B distilled GGUF model right here in ComfyUI. Let's make some lightning fast videos. First, the setup. We need two critical custom nodes, ComfyUI LTX Video and ComfyUI GGUF. Download them from the manager. Both are simple, click install and then restart when asked. For a detailed guide on using ComfyUI GGUF, check the link in the video description. Next, the files. We need the checkpoint V and the text encoder. Model and VAE. The checkpoint and VAE are in one link in the description. For the model itself, select any QUAN you want. I download the Q6 since it's just 10 GB, put it on ComfyUI/models/unet. Save the VAE in ComfyUI/models/VAE. Text encoder clip, we use the one for Flux T5XXL. Choose FP8 or FP16 depending on your VRAM. Save this in ComfyUI/models/text encoders. Let's build the workflow. For loaders, add unet loader GGUF node, load VAE node and load clip node. Select the correct file for each. On the load clip node, select LTXV as the type. For prompting, add two clip text encode nodes for your positive and negative prompts. Connect the clip output to both. For frame rate control, add the LTXV conditioning node. This node decides the frame rate and mixes the prompt conditioning with the frame rate. Connect your positive and negative prompt nodes here. Now for the smart part, STG Guider Advanced. STG is short for Spatio-Temporal Guidance. This is an evolution of standard CFG, applying guidance not just to the image space spatio, but also to the time dimension temporal to maintain video identity and motion quality over time. Connect the model and the positive/negative conditioning from the LTXV conditioning node here. To set this up quickly, use the STG Advanced Preset node. Select the 13B Distilled preset since that's our model. You can always experiment with other presets later. Next, the core engine, the LTXV base sampler. It's the K sampler for LTX. It handles the entire video generation process. Let's set the parameters. Width and height will use the original size 512x768. Number frame, we use the default 97, which is about a 4-second video at 24 FPS. Optional cond indices, key for I2V or keyframing for I2V. Setting it to 0 tells the model to use the input image as the reference for the very first frame. Strength, the denoising strength. A value of 0.8 means 80% of the video is generated while 20% is preserved from the input image. This is crucial for I2V quality. CRF, constant rate factor, controls visual quality vs file size. Lower CRF equals higher quality/larger file. Now connect the model VAE and the guider output to this node. Now we finalize the sampler settings. For sampler, drag the sampler input out and select K sampler select node. We're using Euler. For scheduler, drag the Sigma's input out and select basic scheduler. I use normal with 30 steps and simple. Don't forget to connect the model to this node. For noise, use a random number for your seed, and for control after generation, select what you want. For I2V input, drag the optional cond images input out. Select load image and choose your starting image. If you want text to video, turn this connection off. For now, let's do image to video. Finally, the decoding stage. Add set VAE decoder noise. This node adds noise during the final decoding step to break up artificial smoothness and add texture. Use a low time step like 0.050 and a subtle scale like 0.025. Add VAE decode to convert the latent into the image. Connect the last node and the latent node to this node F in Ally. Add video combined to save the result. Lastly, let's use prompting. LTX is a little tricky, but you could consult ChatGPT or Gemini for this. Please refer to the link in the video description on how to get LTX prompt using free LLM website. And yes, I forget to connect the model to this node and forget to set 0 to optional cond indices. Now run the workflow. Here are the results. It's really inferior to WAN. Now let's try creating a longer video like 10 seconds or 240 frames. The result is strange. Anyway, let's try text to video, so without an image now and back to the original frame count. LTX is famous for its speed and it shows. For 97 frames it took 177 seconds and 240 frames took 526 seconds. For comparison, WAN 2.1 with the light speed model created 81 frames in 200 to 300 seconds. All this was processed using an RTX 4060 Ti 16 GB of VRAM, so while the quality is far inferior to WAN 2.1, with WAN now having coarse-vid and light-speed models, the LTX speed advantage is not as superior as it once was. Here is a bunch of examples with their prompts. Here is a landscape video of text to video. Here is a portrait video of text to video. Here is a portrait of image to video. The first frame is the original image. As you can see, that's why I focused on the WAN 2.1 model and kind of left LTX alone. But it seems LTX2 will be far superior to WAN 2.2 or even WAN 2.5, at least that's what I heard. So that's it for now. Thank you for watching. Don't forget to like, share and comment. And please subscribe to Cao 2025 for more efficient ComfyUI workflows. See you again on the next episode and have a nice day.